All right, guys, page 12. I gave you guys a handout. We'll do that later. Page 12, I want to do stuff from the packet first. Okay. So amplitude, period, phase shift, and vertical shift. Again, this is page 12. Okay, so it says write the function described. So we're going to gather information about our A value, our B value, our C, and our D, and we put it into this form. Okay, so we want a sine function. I'm going to go ahead and write out all the things that we're going to have to fill in. So we need to figure out the A. We'll figure out the B. We'll figure out the C, and we'll figure out the G. So we want to basically replace all the A, B, C, and D's with numeric values. So a sine function with amplitude of 15. So what can we assign that to? A. With a reflection. So therefore what? Negative 15. Okay. Period is 4 pi. So we'll have to go through our formula and figure out what our B value is. Cross multiply, solve for B. Phase shift to the right, pi over 2. So what adjustment do you have to make here? Negative, yeah, negative pi over 2. That's for C. And the vertical shift down 10. What's our D value? Minus 10. Yeah, so your shift vertical is just straightforward, right? Up is positive, down is negative. So we put everything in. Okay. Any questions with number 1? Right. Read number 2. See if you're able to do that on your own. I will work out the same time that you guys are doing it. All right, any questions with number 2? All right, number 3, let's read this together here. Cosine function that's been vertically stretched by a factor of 4 has been reflected over the x-axis. Okay, so what can we gather about one of the values here? Good, yeah, so we know that the amplitude is 4, vertically stretched by a factor of 4, that's your amplitude. Reflected, that's a negative. Period is 2 pi over 3. The compressed, we just have to understand that, you know, we're going to be able to solve for b, and whatever the b value is, that's going to be what it is. So don't have to worry about the fact that, you know, don't do anything different with this, with seeing that word compressed, just have to adapt to our period. Shifted right pi units and down 3 units. Okay, so pretty much same thing as number 2 and 1, just a little bit wordier. All right, number 4. Vertically compressed by a factor of 2/3. What's that telling you? Good, yeah, so anything vertical, stretching or compressing, that's your A value. Okay, page 13. Actually, sorry, page 11. Let's do the other graph that we haven't done yet. Number 14, page 11. So it says write a sine equation and a cosine equation. We always want to try to do the easier one first, get that out of the way, and then we can do the one that where there's a phase shift involved. So looking at 14, what does that look like to you? If in this form, does it look more like a sine or a cosine? Sine, okay. Is it a straightforward sine or is there a reflection going on? It's straightforward, right? That's the original sine function. That's great. We know the period may be a little bit different. We know that the amplitude is a little bit different, but at least it's a sine function with no phase shift. Okay. So let's see if we can figure out what the a value is. What do you think the a value is for this sine function? Okay. Remember, the amplitude is from rest to crest. So from the center to your highest y value, what's that going to be? 1/2, right? So it's just the height, right? And if I go from the center to the lowest value, it's also 0.5, right? So from the center to the highest point, that's your a value. Okay? So we know our a is 1/2. Yeah, I'm going to use the space above, give myself plenty of room here. Okay. We see these increments here. Any idea what the period is for this sine function? 6 pi, yeah. So you can think of it as this 1.5, 3, 4.56. It's going to reach 6 pi here. Or you can back up a little and just go from origin or from center to center, right? So here, -3 pi, all the way to 3 pi. That's the full cycle. If I add those together, that distance is 3 pi plus 3 pi is 6 pi. So our period is 6 pi. We got to make some adjustments, right? We got to figure out what that b value is. So just like the previous problems here, formula. Okay, we know there's no phase shift, there's no reflection, so it should be a pretty straightforward sine equation. Don't have to worry about a C, don't have to worry about a D. This graph is not being shifted up or down. The center is right at 0. So no reflection, right? So 1/2. Yep, you can do theta over 3 as well. Yep. Perfect. Okay. Any questions with that, right? That's the easier one, right? That's the graph that we see in front of us. Now, we want to create a cosine graph out of this. So let's see if we can create a cosine graph with a similar amplitude and similar period. So where can we draw? How can we begin drawing our cosine graph? Where can we start? 0.5, yep. Highest point, middle, lowest point, middle, highest point. Okay, so then you can draw a dotted line here. So now your goal is to write the equation of the dotted line. Okay, write the equation of the dotted line. And then once we get to a point where we kind of have that graph in front of us, we're going to do a phase shift. We're going to push that dotted line into the solid graph. And we got to figure out which direction do we need to move to make that dotted line turn into the solid graph. But a lot of things will carry over, which is good. What's our a value for this cosine graph? Still 1/2, yep. our B value is still 1/3, right? So that's easy. All right, so let's build this cosine graph. And now the last thing we need to do is to figure out that C value. So remember, you're starting at the dotted line and you're moving the dotted line, okay? You're not starting from the solid to the dotted, okay? So you're sitting in the location of the dotted line. What can I do with the dotted line to make it turn into the solid line? Good. You move it to the right by what? 3/2. Good. So let's write that down. Right. 3/2. So how can we make that adjustment in our equation? Say it again. But we want to go right. So remember, everything's opposite with phase shift, right? So minus 3/2. Going from dotted line to solid line. Without that 3/2, it's a dotted line, and then with that 3/2, it's going to be moved into that solid line, which is what we want. We want the equation of the solid line. Okay, any questions there? Okay. Let's go to page 13. Now let's do one where there is a vertical shift. Okay, so this is number 5 on page 13. Guys, we did number 7 and 8 already, so if we want, we can use the space below 7 for work for number 5. And then for 6, we'll use the space below 8. Okay. But I'm going to put it on a separate sheet so it'll be easier to display. Okay, so something a little different about this graph here. What's different about this graph that we haven't quite experienced yet? Is the graph centered at 0? It's not, right? So there's a vertical shift component here. So I think the first thing I like to do is to figure out where that center is. So can you visualize where the center of this graph is? Negative what? -5. Well, -5 looks like the lowest point, right? We want the center. We want a point where the graph is hovering above and below. 4 is a little too low. I think -3, right? -3 looks like it's halfway between -5 and 1. So I want you to draw a dotted line right through -3. Kind of gives you some perspective here. Helps you see where the center of the graph is. Okay. All right, or okay there. Now, we want to do cosine and sine. We want to do the easier of the two. Which trig function does this look more like? Cosine. But is it a cosine with what adjustment with the cosine is being done here? Well, phase shift would mean that it's off of 0, right? So it's not phase shift, but there's something else going on here. It's getting reflected, right? Cosine usually starts high, middle, low, middle, high, but here starting low, middle, high, so it's getting reflected. So we know that means the A value is going to have a what? A negative in it. Okay, so we know that we're targeting that A cosine B theta is easier because there's no phase shift. It's starting exactly where we want to start. We just know that it's going to be a bit of a reflection. Okay, so what do you think the A value is? Remember, your amplitude is from rest to crest. So it's the distance from the dotted line to a point that is that's furthest away from it. So what's that distance going to be?
Negative.
Good. So your amplitude is 2, right? but then there's a negative component because we're getting reflected. So we know our A value is -2. Okay, does that make sense? Make sure that your amplitude, that you're not counting the full distance from max to min, right? You got to involve, you got to count from the center to the max or center to the minimum. That's your amplitude. Okay. Now, what do you think the period is for this function? How long does it take for this graph to complete its cycle?
I/2.
I/2. So starts at minimum, goes to maximum, and ends up at minimum. So is this the full cycle right here?
Yeah.
It is, right? So, I mean, right now, it looks like it's showing us 2 cycles. We only have to go 1 full cycle. So what's the distance of 1 full cycle? R4, right? Okay, so that's our period. Let's go through our formula to find our B value. What's our B value? 8. Okay. All right, do we have everything we need to build our cosine graph? Good, right? Y equals -2. Oh, wait, something else I'm missing here. There is a vertical shift, right? So how low is the graph getting moved? Good. So basically, wherever your dotted line is, that's going to be your D value, right? So my D value is down at -3, so that means it's also matching with how far I'm getting shifted downward. So that dotted line is also helpful because wherever that dotted line is, that's always going to be your D value. Okay. Good. Any questions with the cosine portion? Okay, now let's do the sine portion. Can we create a sine graph that is in the same location, vertically as this graph? So where does the sine graph start? Yep, 0. Which y value? Center, right? Dotted line, right? So we want to start at -3. So remember, you want to create your sine graph so that it's as similar as possible for the cosine graph, except that the phase shift will be different, but you want it to kind of have a lot of similar. So from the center, where's it going to go? To the maximum, right? Which is at 1. Then it goes back where? Center, right? Which is the dotted line. Then to the minimum. And then back to the center. Okay, so let's find the equation of that sine graph. Okay, what carryover do we have? Same what? Okay, close, same amplitude, but the A value is now going to be what? +2, right? Is this sine graph that we have in front of us, is this reflected? It's not, right? It's the original sine graph, so we will make an adjustment. right? The cosine is reflected, but the sine graph is not reflected. So we'll make the A positive too. What's the B value? Yeah, B value is 8. And we have our D value, which is -3. So A, B, and D, that's set in stone. So we can go ahead and write out what we have, and we can figure out the last one. Okay, so now the phase shift here. Remember, we're going from dotted line to solid line here. How far over am I moving to get that to click in place? Okay, let me ask you this. How many intervals am I moving over? One interval over. One interval over to the right. Right? Remember, you're moving the dotted line to the solid line. You're moving to the right. Now, it looks like the graph is not telling us what that interval is, right? Because we know pi over 8 is halfway, we know pi over 4 is full. So what can we do to figure out what that interval is? Because the graph is not telling us. Good, right? So we have a way to find interval, right? We have the interval formula. We have our period. Our period is pi over 4. So exactly right. So period is pi over 4. Interval formula is period divided by 4. Dividing by a number is same thing as multiplying by the reciprocal. So my interval is pi over 16. Okay, so can we say it again? We're moving pi over 16, which direction? Right. Right, you remember, I know it's easy to look at that solid line and move that solid line to a dotted line, but it's not the way, right? We're sitting at the solid line, sorry, we're sitting at the dotted line, and we're moving it to turn it into the equation that we want. So how do we represent pi over 16 to the right in the formula? Minus, yeah. Okay, so I think this is the hardest thing here, trying to figure out the phase shift, especially if the interval is not given to you. You have to take the period, take that additional step, figure out the interval like how you would if you were doing doing your table, right? But you just have to be able to recognize that. So okay, let's try number 6. All right, number 6 is a little bit harder. Let's skip number 6 for now. I'm not going to give you one where it's that messy. Okay. Why don't we do one where we can, yeah, just do another problem where we're doing building the graph from scratch. So let me see if there's one that we can do. Okay, so let's try number 11. Okay, so number 11, bottom of the page 13. Okay, if you need scratch sheet, come up here. I can give you some. Okay. Number 11. What adjustment needs to be made here?
Divide.
We gotta pull the 2 out, right? That 2 is not isolated. With that theta needs to be isolated from that 2. We need to separate that 2 away from the theta. But I need to make an adjustment, right? If that 2 is out, what adjustment is needed within my parentheses? Say that again? Yeah, so I have a 2 in the numerator, I need a 2 in the denominator, so put a 2 in the denominator. Yes.
We're supposed to be doing that on the last couple of problems. Or like we take out the number in front of it for the value.
We should have. Did we not do that for a previous problem? I'm sorry?
I don't think you were up there and that was a little bit. So
Uh-huh.
I had like. It was.
Uh-huh. Which
2
problem?
theta, like 2 theta or 8 theta. It's 8 over 16, 5 over 16. I got it.
Oh, you mean over here?
Yeah.
Okay, so, okay, now if you're building the graph, we don't have to make that adjustment if we are creating the graph, or if you're creating the equation from scratch. If we create the equation from scratch, we're putting exactly what needs to be the phase shift. But if the equation is given to you with the separation not there, then we have to create the separation to get the true phase shift. Okay. So, yeah, so anytime you're building the equation from scratch, you're always going to do things from the easy perspective. So we never have to worry about separating because we're starting the separation at the beginning. But the equation is given to you in the beginning. If there's no separation, then we got to do that additional step. Yes. That's right. So any of the written ones where you are building your own equation, you're never going to have to worry about making that adjustment because you're always going to make it easy on yourself. Yeah. Yes. Sorry, Darren.
When we're making the sine graph, how do we know that shifting over one interval would get us the graph?
You mean the number 5, this previous one that we did? So if you look at this, right, everything is lined up where every tick mark is 2 units away. And if I just shift that tick mark 1 unit over, that's going to get me to line up. So, and I know that my interval is power 16. So once I know that, I know I'm 1 click away. So power 16. Yes. Yeah, go ahead. Okay, good question though. So we have to adjust for that. Yes. That's your question, Jack.
I was just. Said these ones. Like, just keep it out with the parentheses.
Yes, yeah. So if you're building your own equation, you're always going to put it outside your bracket.
Yeah, like you don't need to just turn it into. Easy. You don't have to turn it into this.
Yeah, let me see. No, yeah, I'll do like that. Yeah. Yeah, you can leave all the brackets in place. You don't have to put it in a different form. Thank you. Okay, so We're forced to make that adjustment so that we can clearly see what the phase shift is. Okay, so let's rewrite our new equation. For okay. So we're gonna start gathering all of our information, our A value, our B value, our C value, our D value. What's our phase shift here? Good, left. Yep, left. Vertical shift up. Yes. Keep adding your interval until you reach your period. Leave all your denominators unsimplified. Makes it easier when you have to subtract or add fractions later. Hey, where's the sign start? 0, then 1, yep. Multiply by 3. Phase shift, left 3 pi over 4, so what would that look like in our table? Minus, yep. We're almost there. One last thing we need to do, we got to take care of the what? Vertical shift. So what we're going to do with all these numbers here? Yep, add 0.5. Graphing your very top row and your very last row. It's helpful to put that dotted line, we call that the midline at 0.5, kind of centers your graph a little bit. Your graph is going to be centered at 0.5. You come around and just see how you're progressing here.
Such a deal. We are not this. Few days, like two would change. I just all of the
Well, it was so, think about the side of that. We'll talk about features, but I'm graphing the whole max of the way all they want back. So if you move the minimum, all the way to zero, your channel is gonna be shifted.
That name is not something.
I think you're thinking of a minimum.
It's one of
So the tick marks are. That's. But I couldn't tell you what happens.
They'll say-
They'll eat that apple. That's the word.
Bro. He likes the best. On Moses again.
Hey guys, we want to do another review day for this, so we're pushing this quiz back to Friday. So we'll do another review day tomorrow. Quiz on Friday.